Greetings, folks. This is Grandpa at Gracetime Labs, and you can see all this at gracetime.com, by the way. This is a Myers model for creating hydrogen, and with this particular project I have only 6 pipes of stainless steel ranging in inch diameter, with the cathodes or the inner pipes being 3/4 inch in diameter. And you can see that I've got it setting in a clear piece of PVC, and I've got the PVC stabbed into a conventional, I think they call them clean out caps. The bottom actually screws in, and didn't quite get it completely drip proof. I've had to put a little rag under it. It's not the screw area that's leaking, it's the where the bolts go through to attach to the anodes and the cathodes. So I need to go in and put rubber stoppers or something on them to stop that leakage. It's very slow, but it is leaking. So this is my first ever time to put it in the water. And by the way, the water is ordinary tap water. I just took it out of the garden hose about 5 minutes ago. That's when I discovered the leak. And then I hooked up my pulse width modulator, and I found out that the other day when I was experimenting with it, I think I popped the MOSFET, the power transistor in other words. But not to fear, I've got 24 more with a little bigger amperage rating, so I'll soon have that fixed. But in my curiosity, I wanted to see, I've heard about brute force, and I've got an ICO power supply here that's capable of cranking out about 10 to 15 amps at about 10 to 12 volts. So I thought, well, gee, I'll just hook it up to this ICO straight, without any modulation, without any frequency, without any fancy electronics. It would be kind of similar to hooking it up to your battery, just to see what would happen. And so that's what I'm going to do. I'm going to flip the power supply on, and I'm going to bring it up to about 10 volts, and I'll show you the voltage and the amperage in just a second. But I want you to see something. It really kind of shocked me how efficient this thing is. This is without electronics done. I'm going to zoom in so you can actually watch the bubbling. You can see the water level, and you can see the top of the pipes. Okay, I'm going to flip on the old power supply, and now I'm going to bring it up full speed. Here we go, and watch and see what happens. Oh my gosh, talk about working. Look at how this thing's producing. That's 60 cycles per second, and actually the power running is, let's see if we can get a good clear signal here. I don't know if you can see that, but it's about 11 volts. About 11 volts, running at about 12 amps. And the wires come in to the bottom. I don't know if you can see that or not. The green wire, of course, is the negative. But I want you to see how milky and how this thing's producing hydrogen like I can't believe. And since it's explosive, I've got 2 fans running to be sure it carries it all off. I haven't got a cap on it, so I'm going to turn it off because I don't want to blow the place up. So whether I get the electronics done or not, looks like I've got a fairly efficient hydrogen generator right now. Once I get the leaks fixed, I'll put the bubbler with it. Of course, here's what I'm using for a bubbler. As you can see, inlet, outlet. So, and of course a clear tube to see the water level, and then a blowout on top to prepare for any of those accidents. Anyway, that's the update, and just to show you that things really can work out sometimes. Have a nice day. We'll get back to you when we get the electronics running.